Alright, let's get started with lesson 3, the ideal gas law. Now that we've covered the three major types of gas laws, Boyle's, Charles, and Avogadro's law, we can now introduce the ideal gas law. This is a very important equation that you need to have memorized. So let's draw this, write down the equation for you. It's simply PV equals NRT. Now, P is pressure, V is volume, N is the number of moles the gas has, T is the temperature that must be in Kelvin, and R is known as the gas law constant. Now I want to refer again that the temperature needs to be in Kelvin. So if they give you Celsius, you need to convert the temperature in Kelvin in order to use the ideal gas law. Now let's talk about R. There are two R values here. 0.8206 or 8.314. Now these R values will be used depending on what units of pressure and volume that are given to you. So if you're given pressure of 1 atmosphere and volume in liters, then you're going to go ahead and use this first R value. But if they give you pressure in pascals and volume in cubic meters, then you need to use the second one. And fact is, in order to use the second one, you must have units of pressure in pascals and units of volume in cubic meters. And so you may have to do some conversions in order to use the second R value, 8.314. All right? So that is the ideal gas law, PV equals nRT. The cool thing about the ideal gas law is that you can use this equation to solve for the pressure, volume, number of moles, or the temperature of a gas under any conditions, any situations. So if you have a gas and you know the pressure and volume of that gas, and you know the number of moles of the gas, then you can use this equation to find the temperature of that gas. Or maybe you have a gas and you know the temperature, the volume, and pressure, but you need to know the number of moles of the gas. Then again, you can use this equation quite readily. Now, you can also use the ideal gas law to derive Charles' law, Boyle's law, and Avogadro's law. And let me kind of show you how to do that really quickly, and then we'll move on. So let's take the ideal gas law, PV equals nRT, and let's rearrange it a little bit. So P1 V1 over N1 RT1 is equal to P2 V2 N2 RT2. Okay, so all I've done is kind of put it into a proportion. All right. Now the R values are going to be the same on both sides, so we can actually get rid of those. In fact, I'm going to get rid of the R values completely from our equation and rewrite this N1 T1 into T2. Okay, so the R value we can remove from our equation because it's the same on both sides. So let's say we want to figure out what Boyle's law is from the ideal gas law. Well, in Boyle's law, we know that the number of moles and the temperature are constant. So we can just cross those out because those are constant values. And what do we get left over is P1 times V2 equals P2, or P1 times V1 is equal to P2 times V2. And you got Boyle's law. All right? You can do the same thing with Charles' law. Let's rewrite our equation really quick. So P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. And for Charles' law, remember the pressure and the number of moles are constant. So the only thing that changes is the volume and temperature. So now we have Charles' law. And we can do the same thing with Avogadro's law. Let me re-erase these and start again. So P1, N1, P2, N2. So we know that the temperature is constant and the pressure is constant. So what do we get? When we get rid of those, we got V1 divided by N1 is equal to V2 divided by N2, and we get Avogadro's law. So from the ideal gas law, we can also derive all of the gas laws. It's pretty cool how we can use that ideal gas law. All right, let's go on. All right, let's talk about standard temperature and pressure. By definition, standard temperature and pressure, which is known as STP, standard temperature and pressure. The standard temperature is 0 degrees C, or or 273 Kelvin. All right, and the standard pressure is going to be our standard atmospheric pressure of 1 atm. All right, so those are the standard temperature and pressure conditions. Now, if we use the ideal gas law equation and we solve for the volume of a gas at standard temperature and pressure, so the volume of a gas at standard temperature and pressure would be nRT over P. Okay. Now let's say that we want to figure out what is the volume at standard temperature pressure of 1 mole of gas. So if I have 1 mole of gas times the R value, which is 0.08206, we're using the first one because we're dealing with volume in liters, times the temperature, which is 273 Kelvin. Remember, we have to use Kelvin when we use temperature. That's the standard temperature, divided by our standard pressure of 1 atmosphere, TM. We get a volume that's equal to 22.4 liters. All right. What does that tell us? Well, it tells us that when a gas is at STP, standard temperature and pressure conditions, 1 mole of gas is equal to 22.4 liters. And we've kind of talked about this earlier when we introduced the mole idea or concept to us. So using the ideal gas law, we can actually equate the volume of a gas at 1 mole, or 1 mole of gas is equal to a volume of 22.4 liters as long as we're at STP conditions. And so that's something to note, to remember, and we'll talk about STP from time to time. All right, now you have some problems in your study guides. Those problems we're actually going to do in class. You don't need to worry about them right now. I'd actually prefer to go over them in class with you because there's some things I want to teach you about them. So what we're going to do is we're going to skip to page 12 in your study guide. And on page 12, there's a box there that talks about densities of gas and molar mass. We can actually manipulate the ideal gas to determine the density of a gas and the molar mass of a gas as well. And so what we're going to use is, of course, you know the symbol D is symbolized for density. And molar mass, we're going to use capital M to represent the molar mass. And you remember that the molar mass is the number of moles that's equivalent to 1 gram. And we used that, the molar mass idea when we talked about the mole relationship. All right, so we can determine the density of a gas by taking the ideal gas, and we'll do some manipulation, but all I'm going to do is show you the final result here. The density of gas is the pressure of the gas times the molar mass of a gas divided by the R value, the gas law constant, times T. And T again is in Kelvin. And so this equation here helps us to find the density of a gas, as long as we know the molar mass of it, the pressure, the R value, and the temperature. We also can use this equation to find the molar mass then, because we can rearrange it and we can find the molar mass, which is equal to the density times R times T over the pressure. And that will help us to find the molar mass. So those two equations I want to have in your notes. We will do some problems solving with those two equations. So just be familiar with them. But again, right now, all I want you to know is PV equals nRT. Know what the R values are, and be ready in class to solve some problems using PV equals nRT. So that is it for this lecture video.